Miss Collier explains.
Ratios.
Ratios are used to show the relationship between two or more related quantities. In general, they compare two quantities that are of the same unit, like liters to liters or kilograms to kilograms, and therefore, usually, we don't put the unit inside the ratio. There can be some times when that's different, and we'll talk about that. When we write or read ratios, the order that it is written in is super important. So for example, if I said to you the ratio of boys to girls is 3 to 4. Well, we know then that there's 3 boys for every 4 girl. And we know that because the word boy came first and the first number is 3. And girls came second and the second number is 4. So the order is super important.
So you must understand that doesn't mean there's only 3 boys and 4 girls, but it means for every 3 boys that there will be 4 girls. So let's say we have a party and there's 6 boys there. That means there's 8 girls because there's 2 lots of 3 and 2 lots of 4. Or at a school, maybe you have 300 boys and therefore you'd have 400 girls. And again, maybe in a class or a double class space, you might have 21 boys, which is 7 lots of 3, and that would mean there would be 28 girls, 7 lots of 4. So it's not necessarily that there's only 3 boys and only 4 girls, but that's the ratio of how many boys are to how many girls.
All right, let's stop for a moment and think of some ways where ratios are used in everyday life. As you can see on my table, I've got some here already. First of all, we're going to talk about sport. Now, Miss Collier did something radical and she looked up Premier League statistics. Now, I don't even know who these people are, but they seem pretty good at the game. And this is their goals to shot ratio. Now, we can see Mohammed, he has 72 goals for every 402 shots that he takes. And Gabriel has gotten 37 goals out of the 191 shots that he's taken. So that's a way we can use a ratio in sport to compare their goal accuracy. There's actually a lot of ratios in sport in a lot of different ways. Cement. Now, I don't know if you've ever helped mom or dad cement something. I've helped my dad lay some cement. I was very good at it, I thought. But I've got some cement here, and I'm going to take a look at this, the back of this cement, and I'll give you a closer look. So that doesn't tell me I must put in 1 kilogram, or it doesn't tell me I must put in 1 bucket or anything. It doesn't tell me the units. It just tells me a ratio. And that is a really great thing because I can upscale it or downscale it as much as I need.
Sometimes there are situations where ratios use different units. I'm here in Bunnings in the cement section, and I'm looking at this cement right here. And it says add 5 kilograms to 3 liters of water. So when it's different, we still need to add our units in.
So sometimes we can have our units inside of a ratio, and that is if you're comparing two quantities that are not in the same measurement. The next thing we're going to talk about is cordial. Now, I really think that this is the one that you probably relate to the most. And you may know this cordial. When I was younger, our cordial bottles were much bigger. They looked more like this, and they got more concentrated as I got older. And so here, if I look at this bottle, it says here, mix 1 part cordial for 4 parts water. And this one says, mix 1 part cordial with 7 parts water. So basically what that means, if I take this, this jug and this cordial, let's crack it open. I'm gonna take this little measurement and I'm gonna pour in 40 mils of cordial. So that was 1 part of cordial. So now I have to do 7 parts of water. So basically what I have to do is I have to do 7 more of the parts. Now for my situation right now, a part is 40 mils. So I've got to do that 7 times. Let's go. So there you have it. I've now included 1 part cordial for 7 parts water. I've used the ratio to make what they call the perfect cup. But what about if I take this larger measuring jug and I use 100 mils? So therefore, if I pour in 100 mils here of cordial, that's my 1 part. So this time, 1 part is 100 mils. And again, I've got to add 7 parts of cordial.
I think you mean water, Miss Collier.
So there I go. I've now made cordial again. This time I've got a lot more because my part was a lot bigger. So at no time did they actually specify how much cordial I had to put in. They never told me how much to put in, but by giving me a ratio, I was able to use it to make it as large or as small as I wanted. All right, here are some things we need to remember. The colon is a mathematical symbol that is used to represent ratios. So in maths, or even in life, when we see that colon used in between numbers, we know that it's representing a ratio. When we read it, we say A to B. So if it was a ratio of 3 to 4, or we can also say a ratio is 3 is to 4. So in between the 2 numbers, we put the word 2. Now, what we can also remember, and we saw with the cordial, is if both values, or sometimes 3 values of a ratio, are multiplied or divided by the same number, we produce an equivalent ratio. Okay, so we still use the same ratio to make our small cup of cordial as we did to make our large cup of cordial. So these ratios are still equivalent, and these numbers become equivalent. So let's do that. Okay, so first of all, I used 40 ml of cordial and 7 parts of water. So that's 280 ml. Then the second time I did that, I used 100 ml and I used 700 ml. Now, I really should have picked better numbers, but as we can see here, 40 times 2.5 goes up to 100, and 280 times 2.5 goes up to 700. So these ratios are equivalent because they're still the same ratio, which we know the ratio is 1 is to 7. We call a ratio as a simplest form when it contains only whole numbers, so a ratio can't have decimals, and when its highest common factor is the number 1. If you need to brush up on highest common factors, watch my other video. All right, let's give a go at trying to simplify ratios. So let's look at this first ratio. 3 is to 9. So I have to think, what is my highest common factor for both of these numbers? And I know that that is going to be the number 3. So what I have to do is I have to simplify, which means get smaller. So I know that I'm going to divide. So I'm going to divide by 3. 3 divided by 3 is 1. And 9 divided by 3 is 3. So there I have simplified that ratio. Let's try this next one. 60 is to 24. So I've got to think, what is my highest common factor? And I need to write that HCF, and I need to write what my HCF is. That shows my teacher I know what my highest common factor is. And that is a 12. So I'm going to divide by 12. And I know that 60 divided by 12 is 5. And 24 divided by 12 is 2. So that is how we can simplify a fraction. All right, now it's your turn to try. All right, let's check our answers. I have the number 4 and 20, and my highest common factor is, of course, a 4. It can be the number itself. So I'm going to divide by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. So my ratio is 1 to 5. All right, let's try the second one. 35 to 30. Highest common factor is 5. And I'm going to divide that down. Divide by 5. Divide by 5. 35 divided by 5 is 7. And 30 divided by 5 is 6. So my ratio is 7 to 6. Hope you got those right. All right, let us go back to our Premier League football players. I want to see if I can simplify Mohamed's goal to shot ratio, and in order to compare the two of them. So this is very complicated one, and we're not even going to do the simplest one, but I just want to divide by 2 just to show you how we can use equivalent ratios to compare. So his goal to shot ratio is that he has gotten 72 goals and he shot 402 times. But if we simplify it down, we can use it to compare. So if I divide by 2, that is 36 to 201. And what we can do, see there is, that's pretty close, 36 to 37. So we're kind of, when we've simplified down Mohamed's, we've got them at the same goal ratio. And then we can see that their shot ratio is then pretty close. Hey, we've got 201 and 191. So they're quite similar in their goals to shot ratio. Obviously, Mohamed has just had way more opportunities to take a shot. A part-to-part ratio compares the separate parts. So for instance, it compares the cordial and the water, which are separate. Whereas a part-to-whole ratio compares the part to their whole score. And that's like our goals to shots. So our goals to shot ratio, the goals are also part of the shots, right? Let's try use some of these. Let's try figure out our own ratios. So there's a large enclosure at a zoo and it contains 5 giraffes and 12 zebras. So we need to write a ratio comparing the number of zebras to the number of giraffes. Well, first of all, I see that the word zebra came first. So I need to put the zebra number first, and there are 12 zebras. And then the word giraffe came second, so I need to do the giraffe number second, and that is 5. So the ratio of zebras to giraffes is 12 to 5. Next, I need to write a ratio comparing the number of giraffes to the number of the total animals. So first of all, the first word is giraffes. So I need to put the giraffes first, which is 5. And then the second number has to be the total animals. So I'm going to need to add them up, which is 5 plus 12 is 17. So I hope that helps you to understand the difference between a part-to-part and a part-to-whole. All right, let's quickly check in. I hope now you can see that we talked about the meaning of the term ratio, and we practiced simplifying ratios. And you will know you are successful if you can now go out and simplify your own ratios and form your own ratios. If you've been around for Miss Collier Explains videos for a while, you will know that at the end of every video, you get a picture of my dogs. But this time, I'm going to give you a picture and a video of our school's new support dog, Hero. And that is a little toy I gave him the other day, and he is certainly cute. So maybe he will also feature in our Miss Collier Explains videos. See you next time.